Example 1. Today we're going to look at an actual question from an AP test from 2005. This was a free response question that was on the test. So the first thing they give you is they give you a chart with distance in terms of x, so 0, 1, 5, 6, and 8, and the corresponding temperature for the distances. So the context of the problem is a metal wire of length 8 centimeters is heated from one end. The table gives selected values of the temperature T of x in degrees Celsius of the wire x centimeters from the heated end. So as you get further away, the temperature is going to be, less than where you're heating it up. The function T is decreasing and is twice differentiable. They tell you that piece of information because they want you to know that you can take the derivative twice. Write an integral expression in terms of T of x for the average temperature of the wire, then evaluate it. So first off, looking at this question, we see that we do not have a function. We don't necessarily have a pattern between these values, so we want to write an integral. Now it tells us we need to write it in terms T of x, so we don't actually have to create a function. We could just say an integral. First thing I want to do point out, we're looking for average temperature. So we know that the average of a function is equal to 1 over b minus a times the integral from a to b of f of x dx. So the first thing we need to do is identify a and identify b. Looking back at the chart up here, my first value is going to be a, and my second value is going to be b. So then a is 0, and b is 8. So let's determine what 1 over b minus a is. So this is going to be 1 over 8 minus 0, so this is 1 over 8. And the best way to solve an integral, if you don't have a function, is going to be use the trapezoidal approximation. So let's write the integral first, because the first step says to write an integral expression. So the integral 1 over b minus a to b, t of x dx is going to be 1 over 8 times the integral from 0 to 8 t of x dx. This part answers the first portion of the question. Now it says to evaluate it. So here we go. We're going to use the trapezoidal approximation method. So I think it might be helpful to identify what x1, y1, and all those are. Well, this actually isn't that hard to do. This is x0, x1, x2, x3, and x4. This is y0, y1, y2, y3, and y4. So using the trapezoidal approximation, we're going to get that the integral from 0 to 8 tx dx is equal to height 1 over 2, and the first height of the trapezoid is going to be 1 minus 0 over 2. Again, this is x1 minus x0, and this is h1, times y0 plus y1, which is 100 plus 93. Again, all these values come from the chart. So if I go back up to the chart, you take the difference of these two, and that's going to give you the first height of the trapezoid. So if I draw it out just kind of quick, here's 100, here's 93, and here is 1, here is 0. You get that at 0 you're at 100, at 93 you're at 1. So it's going to come down like this, and this is going to be my trapezoid. I want to find basically that area. So the first height would be 1 minus 0, which is 1. This base is 100, this base is 93. Okay, so that's the first trapezoid. Now I got to do the next trapezoid. So it's 5 minus 1 over 2. And again, this is height 2. And we have to do y1 plus y2 now. And so when we get that, it's going to be 93 plus 70. And you just kind of continue the pattern. And so when you work that out, you'll end up getting, which works out to 605.5. So that's the area under the curve. Now keep in mind, we want to find the average value. So the average value of t is equal to 1 over b minus a, which is 1/8, times the integral, which is 605.5, which comes out to 75.687 degrees Celsius. And that's all the things you need to get a perfect score for that question on the AP test.